On number 3, we're told verify this identity, and all you're going to do is answer, is it true or is it false? So maybe y'all are going to just guess until it says right, or say similar problem and guess until you get it. But let's just see what they have here. This is problem number 3. It says verify this identity. So what we want to know is sine theta minus, oops, forgot my theta, minus cosine theta all squared, does that equal 1 minus sine 2 theta? Well, in order to square this sine theta minus cosine theta, what's the 4-letter word that begins with F? What am I going to do there? FOIL it out, yeah. Some of y'all can do this foiling in your head. So just think of this as my thought process here. Foiling out. Sine theta times sine theta, that's sine squared theta. Sine theta times a negative cosine theta. I'm going to write it negative sine theta cosine theta. And then the next one, if I do the inner ones, is it another negative? It's cosine theta sine theta, but I can write it with the sine theta first because that's how I wrote it right here. And what's the last term going to be? Plus cosine squared theta. So let's see. How do we get a 1 out of this? Here's a sine squared theta plus cosine squared theta. So the two things I've underlined, sine squared theta plus cosine squared theta is a 1. And then the two remaining terms, negative sine theta cosine theta minus sine theta cosine theta, negative 1 plus negative 1, is that a minus 2 sine theta cosine theta? And do we recognize 2 sine theta cosine theta? This is the double angle identity for sine. Sine 2 theta. So sine squared theta, or sine theta minus cosine theta all squared does equal 1 minus sine 2 theta. So yeah, it's true. They're not all 50-50 like that. I like to pick on cosine, the ones that have the cosine 2x, cosine 2 theta and stuff, because those are the ones that there's some, you have some options. Like on this one, which of the following? In other words, simplify cosine 2x over cosine x. How would I simplify that? Well, there's three possibilities here. You could replace cosine 2x. I'm looking at the 3 double angle identities for cosine. They're right there in blue. What would happen if we replaced this cosine 2x with cosine squared x minus sine squared x all over the red? So here's one way we could go about simplifying it. Or you could have replaced it with 1 minus 2 sine squared x. Or 2 cosine squared x minus 1. One of these, we better be able to simplify down to one of those answers that we have there. So, that's okay. If I had to guess, I don't think either one of these is going to simplify down to 0. What do y'all think? The only way it could be 0 would be if what part of the fraction were 0. That top, you're not going to be able to get that top to be 0. Oops, I missed a square here. There. So how can we simplify them? Well, once I show you if there's just one term in the bottom, one thing you could do is separate. Go through and if we separated these, put each one of them over cosine x. Put each of the green terms over the red cosine x. Hopefully we can get one of those to simplify to this stuff we have right here. A cosine squared x over cosine x. If I did this one here, that would just be cosine x, then minus a sine squared x over cosine x. Okay, well, we could rewrite, think of that sine squared as sine times sine x times sine x, so we'd have a tangent. I don't see one of these that starts with, oh wait, yeah, this one right here. Let's keep going. Okay, we might get lucky on the first one. Since one of these starts with cosine, if I think of that sine squared x as sine x times sine x, all over cosine x, and look at what we would have. We'd have the red cosine x, which is right there, then a minus. Is this stuff right here equal to sine x tangent x? Oh yes. Okay. We'd have cosine x minus, I'll write pencil sine x, and then circling these, that would give me tangent x. Years ago, the students saying, oh, why, you're just making these things work out, and that's right. Yes. So, if I had, when I first glanced at this, I didn't see one of these that had a cosine. Okay? This one here, if we started going through it, the 1 over cosine would begin with what? Secant x. So, well, this one has a secant x, but you would then have all of that stuff there. So which one is it? It is D. And we're almost out of time here, so we're drawing my poor version of a pep talk is we're sort of drawing to a close with all this discussion over identities. We still have half-angle identities we need to discuss, but those are the only things we'll do next week. Next week, I'll do a little bit more double angles, and if we need to go back to some of the others, okay. But we have that one assignment left over identities, the half angles. It's a fairly short one, and then I'll spend some time, maybe we'll do a few more sum and difference identity problems, or some more of these double angle problems and so forth, okay?